Today we're going to take a look at the idea of measures of central tendency. Some of these things are going to be very familiar to you from middle school, and there's a couple things that are going to be kind of new. I'm going to push past the older material a little bit quickly. Feel free to ask questions in class or back up and look at the video as well. Spend a little bit more time on the new material. So the three most common measures of central tendency, they're called averages in statistics, are mean, median, and mode. It's a bit confusing because we have a tendency to use mean and average interchangeably, and it turns out that all three of these are examples of averages. Mean is the one that we think of when we hear the word average. And because each of those averages is the middle point of some type of idea of the data, we call it a measure of central tendency. So the mean is represented by x bar, or sometimes by the Greek letter mu, and you know this as the sum of all your data divided by the number of data elements. So we add up all the items and divide by how many there are. This is the mathematical notation for which you may see in some of your more advanced classes. The median. First thing, we arrange the data in increasing order, so from least to greatest. And then we're looking for the middle number in that list. So if we have an odd number of data items, there'll be a single middle number. If there's an even number of data items, then we take the average, the mean, of the two items. So as an example, these are already listed in order. I have 1, 2, 3, 4, 5, 6, 7 items. So 7 divided by 2, that's 3.5. So I'm going to 1, 2, 3, and then the fourth item. So my median, is 5. In the second example, 1, 2, 3, 4, 5, 6. I have 6, which is an even number. So I'm going to take the middle two, the third and fourth items, 3 plus 5 divided by 2. So in this case, my median is 4. The mode is the data element that occurs most often. If there's more than one of the most popular frequency, we say the set of data is multimodal. It has more than one mode. If there's no data item that's repeated, then there is no mode for that data. So let's take a look at an example. We're given a data set, percentage correct on a test to the nearest 5%, and then the number of students who scored that. And we're going to calculate mean, median, and mode of this data set. I'll get you started. We'll pause. You can do some of the work. Come back and check your answers. An important thing to see here is we're not just adding these up and then dividing. This is a frequency table. So there was one student who scored a 40, 0 students scored 45, 1 who scored a 50, 2 who scored a 60. So 2 times 60 is going to be 120. 65 times 3. So you would go ahead and multiply that out and find out that's 195. 6 times 70, 420, and so forth. So we'll total all of these up and then divide by the total number of data points, which is 1, 2, 2 more makes 4, 7, 6 and 7 is 13, so that's 20, 31, 40, 50 total data points. So go ahead and work through the mean calculation, and then we'll come back and check your work. And so when we total up all of these, we get 3930. So we're going to say x bar equals 3930, and we found that there were 50 total tests taken. So we're going to do that division. 3930 divide by 50, and we get 78.6 for our mean percentage correct. Now the median. So in a list like this, we're given a frequency table, and we could actually make a big long list, 40, 50, 60. Well, there's two of those, 60 again, 65, 65, 65, which is fine. But one of the things that we can see is there's 50 total students. So there's going to be 50 numbers in order. My median, because it's an even number, is going to be the average of the middle two, which is the 25th and 26th. So 1, 2, 4, 7, 13, 20, and then I go all the way up to 31. So everything between the 21st and the 31st is an 80. So I have two 80s, and obviously 80 plus 80, the average of those two is going to be 80. So the median value is 80. And then the mode from a frequency table is extremely easy to find. I'm just looking for which one occurred most often. So 80 occurred 11 times, more than any other number. So the mode of this data is 80. And oftentimes we get asked to compare these three. Should they be all the same or close to the same? And we know that if we're dealing with situations of outliers, for instance, most of the scores were between 60 and 100, 48 of the 50, and then there were two that were a little bit lower, a 50 and a 40. So those outliers have a tendency to bring the average down. The median, though, right at 80, and the mode, a little bit more representative of the data set. So when we take a look at measures of central tendency, one of the things sometimes we want to do is be able to organize these things graphically. And a way that we can do that is something called a box plot or box and whisker plot. So when we create this graph, the first thing that's going to happen is we're going to put the data into least to greatest order, just like making a median. We're going to find the median of the data, and that splits the data in half. And we call that our second quartile. Then we're going to take the median of the lower half, which is known as the lower quartile, and the median of the upper half, which is the upper quartile. So Q2 is the median of all the data. The median of the lower half is Q1, the upper quartile, Q3. We also consider what is the very lowest and very highest data points. Those are our extremes, the lowest and the highest. The lowest extreme is the minimum. The upper extreme is the maximum. The range is the difference between those two. Maximum minus minimum gives us the total range of the data. So in the example of that test, we went from 40 as a minimum to 100 as a maximum, so a range of 60. And we also talk about something called the interquartile range, which is your Q3 minus Q1. That gives us everything from the 25th to the 75th percentile, the middle half of the data. So when we make a box and whisker, we're going to take 5 points and put them just above a number line. And these are those 5 points, the minimum and the maximum, and then our Q1, Q2, and Q3. So the halfway point, and then the halfway of the halves. We'll draw a box around Q1 to Q3, and then the name box and whisker, the whiskers go out the max. So we draw a vertical line at the middle of the box, or at the median, which is not necessarily exactly the middle of that box. And so that box is the middle, 50% of our data. So again, here's an opportunity to practice this skill. We're given a data set that is not in least to greatest order. So we need to do that first, and then we can come back and find these values. So go ahead and pause your video, go ahead and put those values in order from least to greatest, and then we'll come back and we'll identify our 5 points and make a box and whisker. So here's our data placed in ascending order, least to greatest. There's 14 total items. So let's start by identifying minimum and maximum. Minimum is our lowest value, 14, and the maximum is the greatest, that's 50. The median of the entire data set, there's 14 items, so we need the average of the 7th and 8th item. So 1, 2, 3, 4, 5, 6, 7, 8. That's these two right here. So 23 plus 24 over 2 is going to give us a median value of 23.5. Now we're looking at just the lower half. 1, 2, 3, 4, 5, 6, 7 values. I need the median, so that's the fourth value, that's 17. So my Q1 value is the median of the lower half, 17. And I should have 7 in the upper half. 1, 2, 3, 4, 5, 6, 7. So the fourth item, 1, 2, 3, 4, 29 is the median of my upper half. That's my Q3. Interquartile range, I subtract Q3 minus Q1. So 29 minus 17, and that gives us a value of 12. Now we go to place our box and whisker plot. So we're going to have 5 points that we're going to plot. Our overall median, which is 23.5. Our Q1 at 17. And our Q3 at 29. And this is where our box is going to go. The median gets drawn right through that point. And then whiskers extend out to our min and max. So there's our minimum at 14, our maximum at 50. So this is our box and whisker plot. There's a couple of things that we can identify. We recognize that most of these numbers are in this range of mid-teens to around 30. And then I've got this value that's really, really high. And as we know, sometimes we're paying attention to outliers. So let's take a look at a couple of things. So the data element that's more than 1.5 times the interquartile range, which is 12, above the Q3 or below Q1. So the interquartile range is 12 times 1.5, that's 18. So 18 greater than this value or 18 lower than this value. Well, we can see 17 to 14, that's not near to 18. But this one, 29 plus 18, if I add those two, I get 47. So any value that's above 47 is an outlier, which in this case, I can see that my maximum value of 50 is known as an outlier. And it's pointed out that sometimes when you see these, that it's represented with an X. So that's a look at the notes. Take a few minutes to go ahead and do your 3-2-1 summary. So 3 things that you learned today, 2 things you want to know more about, a big question that you still have, and plenty of space here for connections, sketches, and random thoughts. And we'll go ahead and do the practice set in class.